Hey, this is Mr. Hendrickson, and this is the Conceptual Physics Tailgated by a Dart Prelab. In this lab, you're not going to need much: a timer, a dart gun, a dart, a car, and a 2-meter meter stick. You're going to line the car up at the 0 mark on the 2-meter stick. Place the dart approximately this far behind the car so that it will clear the gun, and fire.
In order to make sure you have successful inelastic collisions, you want to make sure you're holding the gun upside down, as seen in the photo here. In the coming examples here, you'll notice I'm holding it right side up. Don't actually do that in the lab. You'll find out very quickly it becomes very, very difficult to have a successful collision. So again, make sure you're holding the gun upside down as shown here.
What you'll see is something like this. You'll notice it takes quite a few trials to get it right. Patient.
You're out!
Notice it's taken quite a few trials. Make sure for each trial, somebody is taking the time so that when you do have that trial that does work, you have your data. Don't get frustrated, stick with it, and eventually you'll get it. Alright, so let's say that we've gone ahead, we've performed our measurements for our trials, and it's time to go ahead and figure out how fast our dart and car are moving right when they stick together. So if you'll recall, the measurements that you end up taking here are the displacement of the car. So let's say in this case we measured our car travels a total distance of 0.56 meters, and let's say that our partner measured that the time is about 1.75 seconds. Knowing that our car went 0.56 meters in 1.75 seconds, that should tell you very quickly that we can find the velocity of our dart car combo. Okay, so we know that average velocity of a moving object is, of course, displacement over time. So to find our average velocity in this case, we're simply going to do 0.56 meters divided by 1.75 seconds. If you throw that in your calculator, you should get, I believe, 0.32 meters per second. Now, once we have our average velocity, that's just the average of that dart and car as it moves across the table. Really what we'd like to know is how fast is it moving right when the dart strikes the car. And we don't really care about what happens after that. So how do we find that velocity? Well, the answer really lies in understanding what's going on. The dart and car are moving very quickly at the beginning and then slow down to 0 because they're under the influence of friction. So, if you'll think back to the very beginning, the very first unit of this semester, you'll probably remember another way to find the average velocity of a moving object. And of course that formula is average velocity is initial velocity plus final velocity divided by 2. So we have everything we need here because of course we know that our average velocity is displacement over time. We also know that the initial velocity is what we'd like to solve for. This final velocity, well, if you think about what happened, our car started moving very quickly and slowed down to 0. So, in this case, our final velocity is 0. So all we have to do is plug these numbers in, and we can solve for our initial velocity. So our V average, we said was 0.32 meters per second. Our VI is what we're solving for. Our VF is 0 meters per second, and we're going to divide that by 2. So what you should note here is really all we're doing, folks, is the 0 obviously goes away, and we're going to bring the 2 up over here. So once the math is done, we should find that 0.64 meters per second is our initial velocity. So that's how fast our dart and car were moving right when the collision occurred. Everything after that we can ignore. This right here is the velocity you would want to use when finding the momentum of your dart car combo.